Today, we're going to pull back the curtain on the Active Directory replication model. This is the invisible, super smart engine that keeps some of the world's biggest corporate networks in perfect sync. You know, making sure change made in one corner of the globe shows up everywhere else, like instantly. So let's dive into how it all works. So think about this for a second. It's a massive challenge. If you've got thousands of servers, maybe scattered all over the planet, how on earth do you make them all agree on the exact same information at the exact same time? That is the core problem Active Directory had to solve, and we're going to break down exactly how they did it. Right, let's really frame this challenge. Picture an admin in, say, Tokyo. They reset a user's password. Well, that change has to pop up on servers in New York, London, and Sydney, and not in an hour, but almost right away. And it has to be perfectly accurate. I mean, the scale here is just wild. The goal is every change, everywhere, almost instantly. But you can't just have every server constantly screaming at every other server with updates. The whole network would just grind to a halt. The solution has to be something really elegant and incredibly efficient. So how in the world does Active Directory pull this off? Well, the answer isn't just one simple trick. Nope. It's actually a beautifully designed system that's built on 4 core ideas. 4 foundational strategies that all work together. You can think of them as the 4 pillars holding up this entire structure of data consistency. So here they are: multi-master, pull, store and forward, and state-based replication. Now, each one of these solves a very specific piece of the puzzle. Let's break down what each of these really means, one by one. Okay, first up, we've got multi-master replication. And honestly, this is a total game changer. It means there's no single central master server that everything has to go through. Any authorized admin can make a change on any of the key servers, which are called domain controllers. The best analogy? It's just like a Google Doc where a bunch of people can edit at the same time. This makes the whole system super flexible and really resilient. Next step is pull replication. Now this is really smart. Instead of having a server just blast out an update to everyone, it just sends out a tiny little notification. Think of it like a text message that says, "Hey, I've got new information for you." Then it's up to the other servers to decide when they're ready to connect and pull that data down. It's way more controlled, way more orderly. And then we have the store and forward model. This is what solves that shouting problem we talked about. A server doesn't have to tell every single other server about a change. Nope. It just tells its immediate neighbors, its partners, and then those neighbors store the update and forward it along to their neighbors. It's kind of like a really efficient digital gossip chain. And finally, we have the most efficient piece of this whole puzzle, state-based replication. You see, instead of sending the entire company address book every time one person's phone number changes, the system is smart. It compares its version with its partner's version and only sends the specific change, what we call the delta. This is what keeps all that network traffic to an absolute minimum. Okay, so we've got our 4 core components, but how do they actually play together in the real world? Let's walk through what happens during a single change so we can see how this magic really works. So it goes a little something like this. First, an admin makes a change. That's our multi-master model in action. Second, that server sends a little notification out to its partners. Third, a partner server sees that notification and then initiates the request to get the data. That's pull replication. And finally, once it has the update, it turns around and passes the change along to its own partners. And that's the store and forward model. See how they all link up? It's pretty cool. This comparison really gets to the heart of what makes state-based replication so brilliant. I mean, the inefficient way, sending the entire database for every tiny change, would just be impossibly slow. It would clog up everything. The smart way, the Active Directory way, is to send only that little piece of new information. But to do that, the system needs a really clever way of keeping track of every single change that happens. So how does it keep track of it all? It uses some very clever metadata. First, every single change that happens gets its own unique ticket number, which is called a USN. Then, each server keeps this little scorecard called an up-to-dateness vector, which remembers the latest ticket number it's seen from every one of its partners. So that way, when it talks to a partner, it can just say, "Hey, give me everything you've got after ticket number 5021. It's this super precise record keeping that makes sure no change is ever missed. All right, so we've been deep in the technical weeds. Let's zoom out for a second. Why does this specific combination of models matter so much? What is it that makes this whole design so powerful?
The really crucial point here is that these four models aren't just a list of features, they are a completely integrated design. Each one solves a very specific problem, but when you put them all together, they create this incredibly powerful system that is efficient, reliable, and scalable, all at the same time.
So here's the bottom line. The system is incredibly efficient, right? Because state-based replication only sends what's needed, saving a ton of bandwidth. It's super reliable because the multi-master model means that if one server goes down, who cares? The others can still take changes. And it's massively scalable because that store and forward method prevents any one server from becoming a bottleneck even as the network gets bigger and bigger. It really is a remarkably robust system. But it does leave us with one last, really fascinating question. With this multi-master model, what happens if an admin in Tokyo deletes a user account at the exact same millisecond that an admin in New York tries to reset its password? How does the system resolve that kind of conflict? Well, that's a story for another explainer.